Lesson 7.3, solving equations using quadratic techniques. Now, in order for us to solve this using quadratic techniques, we have to be able to put them in quadratic form first. And by quadratic form, I'm talking about the typical ax squared plus bx plus c, and then we can either use quadratic formula or factor. To decide if something can be written in quadratic form so that you can use that process, there is a simple step that is needed. And that is to take the middle term, and you can ignore the coefficient, just take the variable with its power, and square it. And when you do that, in this case you get x to the sixth. If that is the same thing that leads your equation or expression, then that means it can be written in quadratic form. And what you would write it as would be 2x cubed squared plus x cubed plus 9. And with this being done, you can either factor or use a quadratic formula. And that started with looking at the middle term. In our next example, there is no middle term. So then all we need to do is say, can we write x to the 10th as something squared? And that is true, we can by taking x to the 5th. So that one's a little bit easier, again, if it's possible. Our next two examples, again, we take our middle variable, so x cubed, we square it, we get x to the 6th. Now that is not what we have in the front, so therefore, no, we cannot write it in quadratic form. Fractional exponents, no problem. Again, we take our middle term and we square it. That'll give us x to the 2/3, and that is what we have in front. So yes, we could write this one in quadratic form. And that would be written as x to the 1/3 squared plus 2x to the 1/3 minus 4. Now that gives us some ability. Okay, we have not factored anything that's had higher degree than 2, unless of course we could factor out a variable and bring it down to a power of 2. But this will allow us to factor this anyway. Now first of all, let's check it. X squared squared is x to the 4th. So this is okay. So let's rewrite this as x squared squared minus 29x squared plus 100 equals 0. And let's see if it's factorable. Now if you remember, if we have x squared plus 2x plus 3, whether that's factorable or not, the first thing we did was put an x in the first position of each binomial. That's because x times x is x squared. So what's being squared goes in the beginning of each binomial. The rules still hold true. If it's minus plus, it's minus minus. Factors of 10 would have a sum of 29. That would be 25 and 4. And what happens here is we have factorable expressions again. First one is x plus 2 minus 2. The next one is x plus 5 minus 5. And that tells us that the solutions are negative 2, 2, negative 5, and 5. And this is a degree 4 polynomial, which means we could have up to 4 solutions, and we did. B here is a review of sum and difference of two cubes. In other words, x is being cubed, and 216 is 6 cubed. And the rule for a sum of two cubes was a plus b, a squared minus a times b plus b squared. So if we follow that rule, we would have x plus 6 x squared minus 6x plus 36. Now, from this, we know that negative 6 is an answer. But now we're going to be asked to find the solution for that quadratic. That's not factorable, so we have to use the quadratic formula where a is 1, b is negative 6, and c is 36. So opposite of b, plus or minus square root of b squared minus 4 times a times c all over 2a over 2. So 6 plus or minus, and that is a square root, I believe, of a negative 108. That means that we're going to have a I involved here. So we have 6 plus or minus 108, negative 108. As an I come out, 108 can be considered 36 times 3, which means 6i is now on the outside and 3 on the inside. Now they all have something in common. They can all be divided by 2, which gives us 3 plus or minus 3i root 3. So if it was a cubic function, we could have up to 3 solutions, and we have one solution right here, real, and then 2 unreal solutions. I'll stop that here, and this is the end of part A.